Doing compound and chemical. Okay. In today's prac, we'll be doing a compound and chemical reaction. In this practical, we are doing 6 different experiments as per design on the method section, and we have set up each experiment across the benches, where one bench has got 2 experiments: experiment 1, 2, 3, 4, and then 5, 6. So all you have to do for this practical is like we're gonna do each of the experiment as listed on the prac sheet, and we are gonna show you the observation for each of the experiment, and you meant to actually record down on your result table. And afterwards, then you need to answer the question at the back. For there are a couple of questions where you need to answer. To begin with, we will move on to experiment 1, where we have got a reaction of iron nail with copper 2 sulfate solution, and we need to observe what kind of reaction we will have. And I have already sandpapered the iron nail so that I expose as many surface area for the reaction to occur. So what I need to do is like I need to put 2 droppers full of copper sulfate into a test tube. Just when I put in the copper sulfate solution, I need to be careful not to touch the tip of your dropper onto the test tube, so that it doesn't have to prevent any cross contamination. So we have got 2 droppers full of your copper sulfate solution, and I will carefully slide this iron onto the test tube, and we will start the stopwatch for 15 minutes to see if there is any reaction happening. So we will start the stopwatch, and on another test tube I will just put copper sulfate solution so that I'll be able to compare if there is any reaction at the end of 15 minutes. Alright, I will just leave it there. We'll move on to do the next experiment, and I will come back to this one later on. So for experiment number 2, we are adding copper, and we are adding potassium iodide with silver nitrate. And in this experiment, it's actually a double displacement reaction. So when I say double displacement reaction, it is because like both of the cation and anion of the 2 reactants actually switches place. So the potassium iodide, the potassium ion is actually binding to the nitrate ion from silver nitrate to form potassium nitrate, which is actually soluble because all nitrates are soluble, whereas the iodide from the potassium iodide goes and bind with your silver ion to form a precipitate, which is silver iodide, and you will be able to see the formation of the precipitate later when we add 2 of the solution together. So in this part of the experiment, you are meant to add 2 droppers full of each of your reagent, which is silver nitrate and potassium iodide. So I have labeled each of the test tube with the name of the reagent that I'm putting in. So 2 droppers full of your silver nitrate, 1, 2, and then potassium iodide, 1, 2. For this part of the experiment, you are actually asked to weigh the mass of your 2 test tube that has got the reagent in there, and then after that, reweigh it again once you add 1 of the reactant into another test tube, into the other test tube. So I need to tear the balance, and then I'm putting both of the test tube that has got the reactant in there. You need to record down the mass of your both of your test tube that has got the reagent. So in this case, it's 25.74 gram. Now on the next part, you need to actually transfer one of the reactant into the other one, and you need to see if there is any reaction happening. So at the moment, they are both colorless. So I'm now adding one of them into the other side. So I'm taking the silver nitrate and adding into the potassium iodide. So the moment I add the, silver nitrate into your potassium iodide, you actually see a formation of your precipitate. In this case, it is actually silver iodide. And I'm reweighing both of the test tube in there, and you need to record down the value of the mass, which is again the same as before, is 25.74. Alright, now we're moving on to experiment number 3. In this experiment, we are doing sodium thiosulfate with hydrochloric acid, and we meant to actually see if there is any reaction happening. So there are a few crystals of sodium thiosulfate in the test tube at the moment. Now we need to add two droppers full of your hydrochloric acid into the test tube. Now I'll give it a shake. So if you can see that there is some cloudiness in the solution, to begin with it was a clear solution, and if we leave it longer, the cloudiness is actually appearing to be more, and this is because of the formation of the sulfur that is actually forming that causes the cloudiness of the solution. And if you leave it longer enough, at the bottom of the test you can actually see the solid of your sulfur forming at the bottom. Alright, now the next part of the experiment is your copper carbonate, and we are actually heating the copper carbonate to see if there is any reaction occurring. And if you remember, any reaction of carbonate will actually produce carbon dioxide. In this case, we don't actually test the formation of the carbon dioxide, but we are just looking at if there is any color change from the copper carbonate that before and after heating. So we will just turn on the Bunsen burner. So to begin with, the copper carbonate is actually green, and we're gonna heat the copper carbonate to see if there is any reaction happening. Now you can see a tinge of black formation of your copper oxide forming, and so the copper carbonate is actually being decomposed to copper oxide, which you can see which is obvious from the color change. All right. The next part of the experiment is a combustion of wood, where we're gonna heat the piece of wood using a Bunsen burner. Okay, so I'm gonna hold a piece of wood using a test tube holder, and I'm just gonna burn it. Okay, I'm just gonna leave it on the bench mat. So when it comes to a chemical reaction, wood is actually a polymer that contains mostly cellulose, and cellulose has got an empirical formula of C6H10O5, And in a complete combustion with oxygen, it normally releases carbon dioxide and water vapor. And sometimes it also gives out light and heat as an energy. The last part of the experiment is combining iron powder and a sulfur powder into a test tube and heating up the mixture of the two powder together. So as you know, iron has got a magnetic property. So if I put a bar magnet onto a test tube that has got iron, it's actually attracting itself onto the iron bar magnet, onto the bar magnet as well. Whereas for a sulfur itself, it doesn't have got that magnetism property, so there is no movement when I place a bar magnet onto there. But if I transfer the iron into the sulfur and mix them together, I could actually still move the iron powder using the bar magnet. If you can see that there is still some movement in there. Now we're gonna heat the two of the powder together, and we're gonna see if there is any reaction happening. In this case, we need to heat it up until there is any color change or any reaction that is happening between the two of the mixture. So if I can hold it. Okay, I'm just gonna heat it up. So you are told to actually heat it until it glows. So now I'm actually stopping it halfway there. You can see that there is a color change from a yellowish to actually black, and the black stuff is actually the final product, which is the iron sulfide. And if you put a bar magnet onto the test tube, you won't be able to actually see any of the movement because there is no longer a magnetism property in there. So you see that the iron has already combined with sulfur to form the iron sulfide. So I hope you actually write down all the observation that is for each of the reaction. We will now come back to experiment number 1 to see if there is any reaction that happens. So it's now 11 minutes, but if you look at the test tube, on the iron nails, you can actually see that there is actually a deposit onto the iron nails, and this deposit is actually the copper solid that is actually being displaced by the iron. Iron being a more reactive metal, it is able to displace copper from the copper sulfate solution and to form iron sulfate and a copper metal that is deposited onto the iron nails. And if let's say we were to leave the solution longer, we will be actually able to see the color change between the before and after. We have done another set of thing, so you can actually see that this is before the reaction, which is a blue colored copper sulfate, and after you have added the iron nails in there, there is actually a color change from a blue to a greenish, the yellowish green. The yellowish green is actually the iron 2 sulfate solution that is being formed at the end, together with the copper deposited onto the iron nails. Now that you have got all the observation recorded onto your result table, you actually asked to answer 2 of the discussion questions and explain for each of the experiment. Just a reminder on experiment number 2, the reason why we are told to actually measure the weight of of both of the reactant before and after has got to do with conservation of mass. The conservation of mass state that the mass cannot be created or destroyed in a chemical reaction, so it should stay the same, which is showing from your result as well. So the mass actually doesn't change at all. So that is an answer for your question number 2, and you need to actually put it in your own words to answer the question. All right.